Okay, let's move on to example 2. So we start with our first step, which is using our periodic tables to find out how many valence electrons magnesium has. How many does magnesium have? 2. Okay, so remember, when you write these, you do not put the electrons next to each other because they're negatively charged. 2 negatively charged things repel. So you don't put them in seats next to each other. It's like you getting on a bus. Most of the time, if you get on a bus and there's one other person on the bus, you don't sit in the seat next to them. You like to spread out a little bit. Okay, same way with electrons. Okay, so I draw magnesium, and then I draw iodine. How many valence electrons does iodine have? 7. 1, 2, 3, 4, 5, 6, 7. Okay, so no surprise here. Iodine wants one of those electrons. And magnesium is like, I don't want them. Here, take them. So the first thing that's going to happen is iodine is going to gain an electron. As it gains an electron, your iodine is left with a negative charge. Gained weight, bad thing, plus I'm adding an electron. Okay, magnesium at this point is left with a positive 1 charge. But if you notice, magnesium is not happy yet. It has not achieved the octet rule. It doesn't have an empty bus or a full bus. So this makes you know that in order for this compound to be stable, in order for this compound to actually form and stay as a unit in a chemical bond, you must have another iodine atom come in. So this makes you know I have to draw another iodine. 1, 2, 3, 4, 5, 6, 7. And another iodine will come in and take the other one. So the result of that is my magnesium doesn't have a +1 charge, it's a +2 charge. And I have 2 iodines that have a -1 charge. So my compound is Mg, because I have 1 magnesium, I2. Magnesium iodide. 1, 2. 1, 2. And you can just add another one. You can always just, if it doesn't form a neutral compound, these are neutral, right? -1, -1, +2, that's neutral. In order for that to become relaxed, because the whole reason these atoms do this, the whole reason they do it, is the same reason that you form relationships. Just like Kenny pointed out, because they're less anxious when they're bonded together. They have lower energy, they're more stable. They're more stable atoms, just like people are more stable in relationships. They feel comfortable. So what this is telling you is that this compound, it has a more stable, less anxiety, less energy form than when it's in its single form. Ionic compounds. Okay. On the back of this sheet, for you guys,